Hello, good evening, good afternoon, everyone. Uh, Running through the standard procedure of checking the voice and the videos. Can you guys just confirm if you are able to hear the audio and see the video clearly? You can just type in your responses in the chat box. Yeah, I haven't shared it yet. You guys able to hear me clearly? Okay, guys. Before we begin, I think since it's a first class, I really have not much of an idea how many of us are there. So just wait for another, couple of minutes, and then we can begin it, right? So let's say another 3 to 5 minutes, and then we begin. Yeah, just stay tuned. We will be here. Hi. Okay. So we are 33 right now. Okay. At least we can begin with the first basic intro part since it's the first session. So just quickly run through a small intro part here so that, then I guess most of you have anyway would be knowing about the whole structure of how the GRE is. And I guess, I know you would have had idea of, from the seniors. Actually, it's been quite a legacy, as I know from the VJTI, that mostly a lot of students end up applying for the MS abroad. And the case, in fact, I mean, I had so many of my own friends from the past who had been your alumni, like VJTI pass outs, who have been now doing wonderfully, in US as well as in Germany. So a couple of my friends. So I'm sure all of you also would be looking at really successful careers, whether in India or abroad. Um, okay, now before we actually begin, I'll just quickly run through a small intro of my own, and then maybe you can just help me also know a little more about you guys. So how many of you are from the third year or the fourth year? Which part you are from? How many of you are there from the third year, or how many of you for the fourth year? Yes. So great. Okay. Okay. And the final year ones. You can also just type it in there. Okay. Uh, so I think this, yeah, this whole Corona thing actually has taken quite a toll on, uh, you know, the way things were working, and now everything just shifting on to uh, this online thing. Okay, and mostly I've known, yeah, so many student of my own who were supposed to fly on this year for the courses have to start online again till things becomes a lot more stabilized in there. So we are seeing uh, that's quite a challenging situation as of now, but let's, I mean, hoping that things would ease out a lot more in the time to come. And yeah, surely, like maybe when you guys would begin, I know you will have an option of directly moving on at that one. And in fact, I think it's just the right time to invest in these things, because maybe it will gonna take another year or two for the whole economy to get stabilized, and by the time you would start with your MS and finish, there would be and I'll say another 3 years. So third year you're gonna almost, I see most of you are in the third year, right? Most of you, right? You're all in the third years, right? Okay, third year IT, electrical. Oh, interesting. I had friends from mechanical, production, textile, and yeah, there was one from the I think electronics. Yeah, so four of them in that one. And but that what I was saying, in fact, yes, you're gonna, I guess, mostly third year one, so you're gonna graduate in what, 22, and if you would start your MS in 22, you're gonna, be masters, done with your masters by 24, and I think that could be an ideal time where you're gonna see a good, you know, big jump coming in, because given, let's say, another 2 years for things to get stabilized, then there's going to be a huge demand for the surplus, because whatever losses that uh, the companies would have suffered in this year, they would really like to you know cover up everything, and they would look at a very accelerated growth, maybe not in the years to come, but sometimes when things get a lot more stabilized, then they're going to really push on their their revenues, their targets, to get a good quantum jump in that way. So I think the year 23, 24, 25 is possibly going to see a huge demand. Okay, and just being there at that moment would be an ideal thing to work out like. So it's just like, if I'm job ready by 24, in 23, 24, I think it's just be an ideal thing to work on. Okay, so uh, that's what basically you should also be trying to work on. Say up, just upgrade yourself on your skill sets, just add more skills to it, so that you could have more options to apply for, not just only confounding it to only one single domain, but you can look at the cross domain things. And in fact, the new thing that we have seen, which has been emerged in these coming days, is the blended learning, where it's not just only the core branch that you are into, but again, it's a kind of a blend of the core as well as some application based things. So there are some courses which are, which comprise of the whole core technical knowledge blended with the management sides, something like, say, engineering management. Okay, and if you want to really specialize something into finance, then there's also an option of financial engineering. Okay, you want to get into more applicable part of it in IT, then you have an MIS option. Okay, if you want to complement with a lot more aggressive, but little maths heavy domains, then you can look at data sciences, data analytics, business analytics. So you would see all these, these words a lot these days, and so many universities are coming up with specialized courses in that one, because the way you see the technology is transforming this year, this whole thing, it's moving at a rapid pace. In fact, there was this survey that was there was a report released by the World Bank that said that nearly around 66%, which is two-thirds of the future jobs, are not yet invented. I mean, the things are going to move at such a rapid pace. The things are going to transform so much in just in a couple of years to come, that we can't even perceive what kind of openings of the new domains we would be looking at, what kind of the new job opportunities we would have. It's like, a decade back, nobody would have imagined something like you know, uh, and options like, or you can say a Zomato or Swiggy or anything like that. I mean, when I did my graduation in the end of 90s, I went up doing double graduation. I did my BSc Maths and then BSc Physics, and I'd always be interested in a pure science domain. So I had all my other friends who went for the engineering part. I only opted, okay, because I had a liking for mathematics and physics. So I wanted to build a career in the research part and all that. So I did my double graduation, and then I pursued it with my double post graduation. And always had the problem of deciding between mathematics and physics. So I ended up, doing in both. So I did my MSc Maths and then my MSc Physics for the 2 years, first in Maths and then in Physics. Then I worked at TIFR, Tata Institute of Fundamental Research, there in Colaba, where I interned as a research associate for nearly 9 months. I worked, in fact, I had a chance of working under the leadership of a great astrophysicist like Jayant Narlikar. I was worked on that one in the astrophysics department in that project of it, and then moved on to IIT Bombay, where I was again doing research associate, working as that, doing my research in pure mathematics for nearly 3.5 years. Okay, and then of course the job took over, and then I just somehow got a little disconnected with that part. But I had had an experience of, I would say I was lucky enough to, being at these places like TF and IIT. I had an opportunity to meet a lot of great people about whom we have read and thought of. But I had the option of meeting them in flesh and blood. Okay, so I mean, I call it as a very lucky chance that I happened to meet, Sir Stephen Hawkins in 2000 when he had visited TIFR for a lecture series on string theory. So I was actually, working at that point of time with the TIFR itself. I had my projects on there, so had met him in there, and maybe by now I would have come across or attended lectures, workshops of nearly around, around 15 Nobel laureates, and including, Roger Penrose, as well as the John Nash when he visited Mumbai and all that. But the the one thing that I'm just sharing this experience because that's the difference that you're gonna see when you go to these top universities, be it US, be anywhere, right? And these are the university which boast most of the Nobel laureates. In fact, my own guide who was coaching me for my research, he was an alumni of IIT Bombay again, and he who has done his PhD, his guide, his mentor was a Nobel laureate himself. So when you meet with these people, first of all, you see how simple they are, but then, and they are so rich, with knowledge and the ideas that it somehow makes you feel like, I mean, you're just looking at a mountain of knowledge and you're nowhere. But it's the fantastic experience of learning under their leadership, under their guidance. So I would suggest you have an idle time in your hand, work on your acats, have a good GPA, get a good GRE score, and target these top colleges, because you're going to have an opportunity of not just meeting them but learning from them. There are so many Nobel laureates who teach at these top universities, all the courses that you may dream of. Okay, so I mean, if others people could be there, it's a very strong reason that why I cannot be as one of them. Right? So you have time in hand, and thankfully this whole situation has also given a little, luxury of cutting time on the travel time, which is one of the, worst curse for the Mumbaikars, as we know. you know at least we are spared of traveling through those locals, although we miss that, but still traveling through those locals and the buses and all that. Okay, so you can make the best use of that. I know, try to invest your time, in the skills that you think, you want to learn, or you lack a little on that one. Update yourself, because the way, the world is transforming, you need to even transform. You need to, update yourself at a faster pace. Otherwise, there's always going to be a lead lag game between them, and this is just the right time to do that. Okay, so I'll just quickly run through, first of all, a bit of basics of what GRE is all about, because I know, as I've seen a long span of my teaching career, I've been teaching for nearly 22 years. I've been, for GRE, GMAT. I myself, when I was a student and I was applying for my MS program abroad, I've taken the GRE. In fact, at that time, GRE was supposed to be the paper-based, and that was the last paper-based test that was conducted, I think, in the year 96. And it used to be a 7-section test at that point of time. So if you look at the old papers, there is this big book, which used to be, the kind of the Bible for all the GRE takers there. So you would just pick up balance and do the word list from there, cram. There used to be, around 3,000 words on that one. And then you have the big book, which had nearly around 20 practice test, mock test, and then you do that. And then there used to be a paper-based section where they would have a timer, and then once the timer is done, you have to just move on to the different section quickly. So there used to be 2 maths, 2 verbal, and there used to be, in that time, 2 analytical reasoning, which is the logical reasoning wala part. So they used to call it as an analytical section. And of course the last one was an experimental. So that was the breakup that we had, you know, to maths, to verbal, and to analytic. And the verbal used to be very, very vocab heavy. So you would have questions like, antonyms, synonyms, analogies, which was purely word based. And only the RC part was one where you didn't had, something directly related to vocab. Whereas everything other than this was totally vocab thing. So used to be very, very vocab heavy at that point of time. So I ended up scoring at that time around, this used to be around out of 2400, so 800 quants, 800 verbal, and 800 analytical reasoning. And I ended up scoring 2320 out of that. 2320, which I think in our current scene would reduce to something around 335 or 336 if you scale it, in that way. So it was a fun. This was a fun experience at that point of time. I am sure even, if you look at the GRE, what it has transformed today at current one, it's a lot easier. I would say that it's much, much easier than what it used to be. Quant has always been a strength of all the engineers, as all of you would also know that, quant is something that you guys will simply sail through. You're gonna not have much of a problem in there. So just a bit of a practice, ensuring that you're not making silly mistakes, you're managing your times well, okay, will just be sorted. So I say that you should be looking at nothing less than 168, okay, in your quant section. 168, 169, 170. I would say please go for a 170 on 170. In fact, just I had a student of mine, Bhumi Barcha. She was again from your college itself, VJTI. I think she was from the textile. Okay, and she landed up with a 329, where she had maths 169 and 160. That was the breakup she had. So it was just a couple of years back that I remember. Okay, so it's very much possible for you guys to get out of score in quant, and I'm seriously looking at all of you. I'm saying seriously, all of you, that you need to hit something around that. Okay, if you can get to a 169, 170, it will actually first of all create a good impression on the adcoms if you have a very good high quant score, because being from the engineering background, you're applying to the engineering colleges. It will, you need to have a good GRE quant score in the first place. And again, overall of looking at something around 330 plus. So an ideal breakup that I can say that we should be looking at is somewhere around 168 plus in your quant section and nearly around 162 plus in your verbal section, which will just give you a total of 320 and 330 and above. Okay, so get this figure in your head that this is what I'm looking at in section wise. And if you, as you see, GRE never displays, on their scorecard, which called as a score report. Okay, they never write the total. They always have the quant section separately and the verbal section separately. It's just we add up to, to a more generic score, the overall cumulative one. But on a section wise, okay, if you keep your targets, look at not scoring below 168 and 162. Okay, you should target that. Okay, and it's not very difficult to get to that one. So given, you are almost of you are in the third year and we have still time to go, nearly around 3 to 4 months, which is what we'd be targeting. You can very, very easily get past these scores. Okay, and I'm definitely having this expectations from all of you. I've known the college and the history well, and it's been a lot closer. I had a very nice. I've been with there a couple of times and had a good experience, whether it was your fest or the robotic competition. I guess this is still happening at that time, right now. So sure, I mean, we all should be there, and let's take up a challenge and let's get to that, right? Okay, now coming back to the running through the basic structure. Okay, as you would know, you will see there are it starts with an AWA, which is an essay. So you're going to have two essays to write. One is analysis of an issue, and the other is analysis of an argument. Okay. So each one is scored on a range of 0 to 6, and then the scores are averaged out. So these would not have any contribution to your overall scores as such. Okay, so this is just gonna be, 1 hour tasks, which means you're gonna start your quant or the verbal section after an hour. So this essay thing might be a bit draining, because you've already spent 1 hour typing out and constructing the essays and working it out. All right, so a good amount of practice would just get you sorted at that one. And then you start with either the verbal or the quant section. Okay, you're gonna have two quant, two verbal, and one unscored, which could be either a quant or a verbal. That's what you call as an experimental. Could be anything. Okay, now that means you're gonna have now this research section is actually uh, optional. Not everyone end up getting that. Okay, so it's only for a few of them, and I'll explain how the questions on the research section are different from the unscored or the experimental section. So this experimental section is usually the set of new questions which are going to get, be live as a part of the test in the future. Okay, and they're definitely going to be as a part of that test. So the whole algo of how GRE works, that we say it's a section wise adaptive, which means uh, you always start with the first section as a mixed medium level of difficulty, and depending on your accuracy in that, the level of difficulty of the second section is decided. We say it's a section level adaptive test. Okay, it's a sectional adaptive one. So of course, tougher sections would have higher weighted scores, and easier section would have lesser scores. So if your accuracy is nearly around 90% or above, which means out of the first set, which has 20 questions in quants to be done in 35 minutes, if you can manage, let's say 18 or above, not making not more than 2 mistakes, you're gonna get a tougher section, which would be a tough one, and hence has a higher weighted score. If your accuracy is somewhere around, 75, 80, then you're going to get an average section. And if your accuracy is, again, less than average, which is, let's say, less than around 60%, so you get around less than 10 correct. Okay, so around 50, 60%, then you're going to get an easy section. And hence your overall score would be decided. So it's a combination of a medium hard or a medium or a medium easy. Okay, ensure, by no means that you get a difficult section in the second one. Okay, otherwise it may be, a little problem of even getting to a 160, which is a minimum, the minimum criteria for all the top 100 universities, that they expect you to have at least minimum of 160 in the quant. Okay, if you look at the top 50 and all that one. So you need to have a very high accuracy in the first section. Okay, you should not mess with that. So ensure that you get either 20 on 20, or even if you're making a mistake, you don't make more than 1 or 2 mistakes in that section. Please keep the accuracy more at around 90 and above. Okay, so that's what they will decide on the overall score. So whether it goes too close to 170 or it's around 150s or 130s. And even if you see, the minimum score that you get in the quant section is 130 and the highest is 170, which is a difference of, 40 points. And you have two quant section, which will have 20 and 20 questions, which are 40 questions. So these 40 questions, and then there are 40 points, but they are just not like, every question is weighted by 1 point and do that. So every question in the same section has an equal weight. The questions are not graded differently within the section. So, whether it's DI question or a PNC question, or maybe it's a simple question on percentages, the the level of difficulty, it doesn't vary much. So the scores are all the same, but it's the sectional weighted scores that would vary. And hence that's going to give you a little higher score if you have a tougher section as compared to the medium one. Okay, so ensure that you get a difficult section in the second one. Okay, now see, sometimes it's actually a random thing, you know, how these 5 sections are going to turn up. So it's going to be 2 quants or 3 verbals, or it could be 3 quants and 2 verbals. So you can start with a quant and then do a quant verbal, and then maybe a quant if you get 3 quants. Or possibly you can have start with a verbal, and then you can have, you know, even some of the same section back to back. In fact, just a couple of days back, I was having you know, just talked with one of my GRE student who were scoring pretty well in the mocks. She was getting around 328, you know, 328, 325, 328, but she ended up with, you know, 316 in the final score, just because the first 3 sections that she got were all 3 verbal sections. Okay, now if verbal is your strength, of course, then that's no problem. But I mean, again, she had a background as an engineer and her strength was quant, but she added 3 quant section, you know, sorry, in the first three as the verbal sections. Okay, now that makes it a little challenging because doing 3 verbal section back to back becomes a little tiring. It's actually mentally exhausting. Okay, so there's something that, and it's very rare, you know, it's maybe, you know, the second or the third case I've heard in the entire span where you had just, you know, 3 verbals back to back. So someone who's looking for a quant section, because, you know, to start, to have a good start is the most important thing. You know, we have seen in cricket, the first 15 over matters a lot. If you had a good start, then, you know, the rest of the time, you know, the rest of the time is taken care of. So, you know, you're looking for that part. And then suddenly, if you have, like, say, a verbal and then a verbal and then a verbal, you just might, you know, somehow in way lose an interest in the test itself, or maybe just somehow try to, you know, get a little mentally exhausted that it will take you some time to recover and then come back and work on the quant section. So you need to be prepared for all such eventualities, all such possibilities. And when we practice on the mock parts, we just ensure that, you know, every kind of this combination has been taken care and worked out. So if you're gonna be in this situation, what should be my strategy and all that? So that is all, you know, we discussed sometime somewhere during the mock analysis part of it. Okay, so that's how, and that's it's been become recently, and it's been an interesting mix of it. Okay, so accuracy plays a very important role. So generally in overall quants, you know, they won't be asking too many, you know, questions on a higher, which are based on the higher level of difficulty. So if you would see, okay, not more than around 150 concepts are getting tested on GRE. When I say concepts, you know, find, let's say, arithmetic mean, you can consider as one concept. So mean, median, mode, like there are 3 different concepts. Okay, so let's say in a geometry, you know, you can say, you know, finding the slope of a line and applying this to find an equation of a line could be again one concept like that. So basically, you know, overall, if you see, it's not more than 150 different areas of the concepts that getting tested, not just the areas. Broadly, they test you only on 4 major areas, which is arithmetic. And this arithmetic would cover all the questions related to percentages and the applications. So percentages as a basic concept and its application in profit and loss, simple compound interest, and mixtures and allegations. Okay, then ratios is there, averages are there. Ratios will have its application in concepts like time, speed, distance, and rate and work. And then we have algebra, which will cover through the linear, you know, equations, simple, simultaneous, quadratic equations, and then you're going to have your inequalities. Now, inequalities at some point, it's a bit challenging, slightly, you know, more challenging than the equations. Otherwise, it's very easily, you know, a sorted thing to work out. Then the entire geometry, which is 2D, you know, 3D, as well as coordinate geometry. That's the 3 border areas. And when the 4th category is data analysis, which would comprise of the DI, graph-based questions, line, bar, pie charts, and statistics. Okay, and then part of PNC and probability, which gets covered in that one. So broadly, these are the four areas that you're going to be tested on. Most of the things would be relevant to 10th standard, except some concepts, based on 11th and 12th. Not everything of the 11th and 12th, because we also end up doing a lot of analytical geometry, direction, cosine, direction, ratios, vectors, and all that, and even in a lot of calculus, but that's not going to be a part of the GRE quant. So majorly everything that you studied till 10th and some portion of, the 11th and the 12th, like functions, okay, and permutation, combination, probability, sequences, and all those limited areas of it. So overall, if you see, it's not a math as such, okay, it's just the basic quantitative skills. So you don't call it as a math section, so that's why you call it as the quantitative sections, because it just tests you about how good and familiar you are with the numbers and the other concepts, and how you can apply it to the real life problems, which are what we categorize as word problems. Okay, so what are the the area, okay, in the previous one, like what are the skills that GRE would test you on? Okay, if you look at that part, so it's generally try to test you, on reasoning, how good you are with the reasoning part, the analysis, whether you can make a good analysis from the given problem. You can just analyze the data and work it out. Okay, inferences, in some cases, you just not be needed to solve it. Like there's some statistics questions where you may not need to calculate, but infer from the given data. And approximations, maybe, although you have an advantage of having a calculator, on-screen calculator, but then again, we Indians are already good with mental mathematics. So I would suggest that don't be that much dependent on calculator part, because it's an on-screen thing and it's quite tiring. So you have to go and do the clicks. The numerical keypad is disabled, so you cannot enter through that. You have to go in and click it on the numbers and work. So it's quite a cumbersome thing. Okay, and anyway, I mean, we are adapted to doing a lot of mental calculations, so it won't work. Only for things like, finding square roots in some cases, or some long multiplication or division, you can use that. But most of the calculations that we do would reduce to maybe, number-based, or mental calculations. Anyway. So in the end, as I often say that it's nothing but just a, bloody American test. So Americans are so much used to these, calculator things. So leave it for them. We don't need much of it. Okay, now here, what it tests and what it won't test you. So GRE doesn't test your calculation speed, knowledge, and more in-depth knowledge of mathematics and all that. So it's not gonna test you whether you're gonna have a skill of becoming a mathematician or so. Okay, that's just whether you have a basic ability to think, and analyze. You can, are easily able to quantify things and relate it to practical problems. Okay, so it's the skills like focus, decision making, and how much detailing you can, attempt to. So the important point on GR is the language, the way they frame the question, and that is, the most critical part of it. That instead of putting it in a very simple language, just like what you see on CAT. That's a one basic difference what you see in a CAT question and a GRE question. When I'm saying CAT questions, CAT is relatively difficult than GRE. CAT quant is quite difficult than GRE quant. Okay, but even if I'm comparing an average question of CAT with an average question of GRE, which you can say it's at the same scale, the CAT question would be a lot more straightforward. So there won't be any tricks involved in order to understand or decode from the statement. It will be very evident and clear. But GRE, on the other hand, would just make it a little twisted on the language part. It will never give you things very directly. It'll always try to twist it. Make somehow a trap there, and see whether you could actually unlock or decode that and work. So instead of saying what is X% of Y, okay, where we know, or X is what percent of Y, where I'll say I have to find X as a percent of y. So x is the numerator and y is the denominator. They would just, twist it as what percent of y is x. Generally, in a hurry, I would say the first number is the numerator, the second is the denominator, because it's a game of is and off. The off is the denominator, is would be usually the numerator part. So instead of saying it what x is what percent of y, they would just twist it as what percent of y is x. So in a hurry, you may just end up, misreading that or reading from your, muscle memory. It's like as you've been used to, and just work out like y by x, and end up making a silly error in that. Okay, so these are the things that you're gonna be a little focused and worked out with. Okay, now let's quickly move on to the concept part, where let's look at this and start off with the first session. So in the first session, we're gonna go through the part of number systems, okay, which is the first area that we would start with, the questions which are based on number theory. And we're going to cover up in usually 2 sessions. That's today, a part of it, and another in the next part. Okay. And I would really want if you guys can make this session a lot more interacting, because that is one challenge that I see is, happening as compared to the classroom based environment, that, you cannot interact at that level. The kind of the interaction we have in a classroom with the students, where there's a lot of discussion happening out. Okay, that's one drawback that I have found on this online part. So if, we can try to bridge that gap, and then if it could be a lot more interactive, I would like that. So um, you can just quickly post your queries, questions, or maybe, somehow, work it around. I think it would be a good two-way thing that can make the whole sessions a lot interesting. And at any given point, if I would honestly would like to take feedbacks from you guys as well. Then if you find me going a little fast, then you can always tell me to go slow and explain. And if at the same time, if you think that it's going a little slow, then you can also tell me, sir, this is a little obvious, let's try to go a little fast. We can also work that out. Okay, so I would expect that same things coming up from you guys as well, and maybe a more of the discussion that's we can do it on. Okay, on both the sides. All right, so we would start first with this one, the number systems, the class for that one. I'll share the PPT, and just let me know if you guys are able to see this, if it is visible to you. Okay, I have one question, that why is GRE not testing the engineering knowledge? Okay, all right. Before I start with my, that the quant section, see, it's more like an US system. Okay, so in US it is compulsory for every undergraduate to take a GRE and apply for the graduate program. The graduate there are the master's program. So that is kind of a criteria for them. You cannot apply to the master's program unless you have a GRE. To all the good universities, they would want you to have a GRE. So think of people from the engineering background who want to go for an MSc again in engineering. Okay, so there are a lot of people from engineering, or what we call as actually as a STEM. They have a concept called a STEM, which is all the branches that are more applicable in the practical life, which which affects and which has a lot more contribution in the to the practical side of life. So science, technology, engineering, and mathematics. So they've designated that these 4 domains, which has a lot more practical application as compared to the others that you have. Okay, in terms of the technology and all that. So people from these background who would go into their own field would have to take the GRE. But I can, at the same time, people who are from the non-math, the non-STEM backgrounds, something who are from the socials, the social studies, the fine arts, the literature people, who have done a, let's say an arts course in English literature or psychology and want to go into the master's program in literature and psychology, then they don't have that much, kind of the grounding in mathematics as engineers. Okay, and all that. So this test, it should be designed in such a way, and it's a very interesting thing, and that's how they do so much of research, that any question on GRE should not become biased towards any stream of the knowledge. So they don't want to have, a verbal section which would be more biased to the people from the verbal background, and so that they get the edge over the non, verbal people, like say engineers also, as we have already seen. And they also don't want to make a quant section, which becomes more biased towards the science or the engineering people, and the other fields, sound like, the social studies, or maybe the arts people struggle with that. They want to have this test to be fair enough so that everyone has the same chances of scoring well on this test. So that's the reason why, they avoid asking questions which are a little more advanced. So engineering, so if I have a question which is very much based on engineering, let's say I ask a question on calculus. So there are so many streams who would not do the calculus part. So that becomes more biased towards, people who are from the, you know, more mathematical side, who can do these problems more comfortably as compared to the other. So this is one reason why they want to keep it at a very basic level, because the bifurcation usually happens post your high schools, and even at some time at the high school also, that you end up choosing some of your specials. Okay, but till 10th standard, you have a very uniform education. So whatever career path you take, that's decided basically after your, secondary schools. So they would have most of the syllabus, which is common to everyone, and hence they have questions only majorly restricted till 10th standard, and then some part of 11th and 12th, which would say it's defined that more relevant, you know uh, that someone who has to know, and then only those area which have more, kind of an analytical, or inferential part than the mathematics. So things like PNC and probability, if you look at the questions on PNC and probability, they are more of the inferential parts. There's more of the analysis, the thinking that involved in it, more logical than actually mathematical. So when we look at the sequence and series, there also we see there are questions, which are more the basic level and more logical than you being a very, a tough set of questions. So no Fourier's, no Laplace, nothing of that sort. Basic. In fact, they don't even categorize or call these sequences as arithmetic or geometric. They just call it simply as a sequence, and they define the sequence as a function. So there is a rule given and there is a condition. So can you understand the rule and apply this condition as per that rule and get an output? This is the simple process that they have broken down to. Okay, and that's what basically they see. Okay, do you have the skill of understanding a rule, and for a given input, you can find the relevant output by applying that rule to that problem. That is the basic construct, and that's why, because that's a basic skill that they would like to test from anybody from a background. So that's one of the reasons why. Okay, now I'm just going to share this PPT here, and just guys, if you can just confirm if you are able to see this. Yeah, if the visuals are good. Okay. Uh, right. So we start with the first session, which is about numbers and progressions. Okay. Now, when we talk of, first of all, the number system here, okay, the number system, we look at how, first of all, the whole idea of numbers or the classification of numbers being worked out. So instead of directly going on to, the other parts like factors, multiples, and work it out, right? Let's first quickly run through the basic understanding of what these numbers are, and if, you know, how these numbers are being classified in that one. So we've been, used to seeing numbers defined into various category of sets. So, we know that we started off first with the set of natural numbers, which is also called a set of countable numbers. Counting numbers, countable numbers, right? It starts from 1, 2, 3, 4, and so on and so forth. So the name naturals were given because, what we count in the real world is nothing but, the natural objects. So see, first of all, when you look at the number, basically, why there is a need of inventing a number? What is a number in the first place? So unlike, other physical sciences like physics or chemistry or bio, where you see the processes in, how the nature behaves, you're trying to understand the process of nature and try to express, those into a language that, we can comprehend and exploit and, in fact, optimize on. Okay, mathematics is one thing that has completely evolved out of human experience. So there was no practical side to it. There was a requirement and hence the whole invention. Okay, but it's not that that was what is existing in the nature and then you try to comprehend and you made a theory out of that. So when we look at these numbers, it's one of the most abstract concept or that, that got evolved, because of us. We came up with a notion of this type. So when you're looking at a number, basically, what does it mean? What does it denote? So if I'm looking at, a 7, what is it? What is the meaning of this one? So if I try to, define this is nothing but just a symbol that I'm using. Okay, this is just a symbolic representation of a count which would, measure something like this. So if you would know, in basic statistics, we have done this part of what you call as classification of numbers. Sorry, when we were tabulating the data there, so we would make these, class tally that one. So basically, these numbers are nothing but, some set of symbols that we use to help us count things, because that's the first purpose, that we use these numbers to. So if you read about the whole history of evolution of these numbers, you would see the different, different kind of people have used different symbols, different set of processes where they would count in their one. So if you look at the Mayan has a system which has 38 symbols. So they would calculate, their whole calculation worked with 38 symbols. Even we Indians in our olden years before, everyone ended up adopting a decimal system. We had a system where we were using 18 symbols in the past and all that. So everyone has his own set of symbols and they would use these symbols for their own whole sets of counting purpose. So right now what we have agreed and adopted is a decimal system, right? So we follow a decimal systems, as we all know, okay, which comes from, deci, MAL. So decimal comes from deci, as you would know, and which is related to 10, and an MAL, which is like numerals. So deci also works from a process, where things are related to the powers of 10, and hence, we worked on that one. Okay, so everything in this system is expressed, in the groups of 10, and we use only 10 symbols to define that. So these symbols 0, 1, 2, 3, 4, and up to 9, which is what, they are called as digits. So these digits are nothing but the 10 symbols that we use, okay? And we in different linear combinations with the place values. So we make a groups of singles like here. So we can have maximum group of singles of 9. And then we make a group of 10s, 10, 10 each, and then we can repeat this group of 10s. So let's say if I have a number, that's, something like say a 75, which means I have taken 7 groups of 10 and I have 5 singles. So this is a group where you have 10 sticks, and then you have seven bundles of 10, and then you had 5 of them. So that's how it worked out. And that's how they see it's interesting how the whole idea of, comprehending this grouping things evolved in the primitive people, like, for forefathers, like how would they work out? So they are making big and bigger groups, bigger bundles. So the maximum that you can reach here, okay, is 9, because you cannot have more than 9 bundles because you don't have a symbol beyond that. So the moment you have more than this, if you have to add one more bundle to it, so let's say you're gonna have 9 of these, okay, 9 of the bundles of 10, and you want to add one more to it, okay, then I don't have a symbol to denote that. So what I'll do, I'll make a one bigger group to it. Okay, and that's how this becomes a group of 100, because now you have these many of them. So that's how the values, the place value came into the picture. Okay, why they were taken as a powers of 10? Because at the max, even if you have constructed, things in the bigger groups of bigger bundles, you cannot go beyond 9. So the moment you add one more, then I don't have a symbol for it, and hence that becomes a larger group. So that's how you denote it as 1 0, because that 10 is not that one. So you have shifted from a smaller bundle to a larger one, and hence worked out like that. So keep on making bigger and bigger part. So now if I had to put it in a very mathematical form, and say any number n, okay, can be symbolically represented as a linear combination of its digits with the place values. So if there is n digits, so you can say a into 10 raised to n plus b into 10 raised to n minus 1 plus c 10 raised to n minus 2, so on. Let's say, m into 10 plus n. Okay, if these are the different symbols that you have taken and worked out. So using all different symbols and all that. So it's just a symbol linear combination of any number. So you can break it out like that. Now on the decimal side, so if I have 31462.5987, so these place value starts with 0, this is 1. Okay, although this is very basics, but I'm just quickly running through that, and there's gonna be 10 raised to 4, which are the bigger parts of it. So this is the units, this is the tens place, this is the hundreds, thousands, 10,000s. Okay, so working out like that. And on the other side, if you see the right of the decimals, these are the fractional parts, which means here we are multiplying by, parts of 10. Here we end up dividing by them. So you divide first by 10, and then you take the 10th part of it, and you divide by 100, taking the 100th part of it, the 1,000, the 10,000, and so on and so forth, which are denoted in the negative powers. So 10 raised to minus 2, it's minus 3, 10 raised to minus 4. And to this one, you're taking the smaller fractional part of that. What is 1/10 of that? You're taking 100th of that number, and so on and so forth. Okay, so remember the way they would ask, because again, there has to be a catch here. So round off to the hundreds place. So this is 100, HUNDREDS. And whereas if you take this one, that is the 100th, HUNDREDTH, 100th, because it's 100th part of that. And that is the 100 times of that. So these right side would end with the TH, the 10th, 100th, 1000th, and there it would be tens, hundreds, thousands. So in a hurry, you get, it's a very common, it's a very, very common silly mistakes. I'm sure it's not just because of the lack of knowledge, but then it's like due to hurry. So you end up reading the 100th as the hundreds. Okay, end up rounding off in a wrong way and mark a different answer accordingly. So this is what, and be just careful about reading and marking on that one. So likewise, the whole, the number systems evolved, and then you categorize and classify them on the basis of the same properties. So natural numbers, which are used only for the purpose of counting. Okay, that goes to infinity. There's no end to it, but the smallest one to start with is 1. So 1, 2, 3, 4, 5, countable numbers. Okay, and since we count natural objects and hence the name natural numbers, then the great Aryabhatta came into the picture, you know, the contribution from India. And then he said that although what you're trying to, quantify are all the things that you see, but even if there is a lack of anything, that is also something that can be quantified. So the idea that he proposed was quantifying nothingness. So if there's nothing, so let's say if in a class, let's say how many students attended today's class. So if I'm looking at the number, I'm saying, okay, in today's class, I see there are around 55 people. So I have quantified that. But suppose, in one day, after some days, then once our course get over, and I say, oh, how many students are now in the class? I said, no one, everyone passed out. So there is no one in the class, which is zero. I mean, when I say no one, then how do I try to quantify that? So he said that even nothingness, okay, or a lack of something is also a quantifiable object. You can quantify that, and hence he invented the symbol zero for that. So then he said that everything in the whole world could be quantified. Things which exist and can be counted, and things which don't exist. So you had 0, 1, 2, 3, 4, and all that with 0 added to it. And then name was given as whole numbers. The whole numbers because it just simply meant that, everything in the whole world or the whole universe is now it's quantifiable. Okay. And then we adapted to more advanced set of processes. Then it was just not merely the process of counting, but also the calculation evolved into that one. So there was the need of something which is much more more practical than just the numbers for the counting. So here there were situations where you need to define the excesses and the deficits. So if let's say somebody needs $10 and you have 15, so after you have given him $10, you're left with 5. But suppose you had only 5, then you cannot give him 5 because you are less, and you have less by 5. So in either case, the count is 5, but the meaning is totally different because in one case you have 5 more than required, in the other case you have 5 less than the required. So just the symbol cannot inform that. Is not able to tell you okay, whether it's 5 more or 5 less. You needed something else that would explain that, and hence the idea of signs were invented. So the excess part is denoted by the plus sign, and the less part, whenever it is lacking or it's deficit, you denote it by the negative. That's why percentage gains are denoted by plus percent, and the percentage losses are denoted by minus percent. So for every gain, you can have an equivalent loss. So just like you have plus 1, plus 2, plus 3, you can have 1 more, you can have 1 less, you can have 2 more, 2 less, and so on and so forth. But in the case of 0, okay, then the idea of sign didn't work. It's like I need 10 and you have 10. So after you've given me 10, how much more you have? You say, I don't have anything. So I have 0 more. Or you can also say, I have 0 less. In either ways, it's correct. I mean, there's no way I can refute one over the other. So there we see that, the idea of sign doesn't work for a 0. So we say 0 is neither positive nor negative. In fact, in the earlier days, it was expected that 0 is both positive as well as negative, but that would lead to a lot of confusion there. And so that's why it was finally accepted that 0 will have no sign to it. So 0 is the only exception, only number which won't have any sign attached to it. So there's nothing like say plus 0 or a minus 0, it's just 0. But for any other number, we have its plus as well as the minus counterparts. This is what you call as a set of integers. Okay, now if you look at the GRE part, okay, the GRE one will not deal with these basic set definitions. They won't go into the, the natural numbers or the whole numbers. The basic starts from the set of integers, and then they subclassify. They make subsets out of these integers to define the natural numbers and the whole numbers, right? So if you take the whole positive part of it, it's right from 1 to n going on to infinity, this is what we call as a set of positive integers, which you see is equivalent of natural numbers. And then you have all the negative numbers taken separately, which is a set Z minus consists of all the negative integers. And then since 0 is neither positive nor negative, you cannot make it as a part of any of the set. And hence that's kept separately. So when you say X is a positive integer, it means it's a part of Z plus, right? But it can take any positive value. But when you say X is a non-negative integer, okay, this is again, the language where they try to trick you. When I say it's a non-negative integer, it's not a negative number. It doesn't mean it's only positive. This would mean it's 0 or a positive integer. So it could work as a 0 or a positive integer. It could be just a union of both, which is an equivalent of your whole number. So the set of natural numbers, okay, this is the equivalent to the natural, are referred as positive integers, where the set of whole numbers is expressed as a non-negative integers. Okay, then another property of integers, if you try to express them in the decimal form, okay, they are either terminating or recurring, which means if you try to express them in the decimal form, it's like 1 by 2, which is 0.5, or 1 by 8, which is 0.125. They will end, they will terminate. But if you take decimals like 1 by 6, which is 0.16666, that keeps on recurring. Okay, generally the recurring part is denoted under the bar. Or you take 1 by 7, which is 0.142857, and the whole under the bar, that shows the whole block 142857 repeats. So it's like the repetition of 6-digit blocks, one after the other, one after the other. So, okay. So either ways, whenever a fraction is expressed in its decimal form, it's either be a terminating, it'll end, or it would be a recurring, or it would repeat. It cannot have any other representation. This has to be only the two forms it should be. So every fraction is either terminating or recurring. But there are certain numbers that been observed, that doesn't end or they don't repeat. So one such example, which you can conceive of, is a number that I can construct by writing 0.12345 6. Okay, just keep writing all the natural numbers one after the other, so on. Now, how long will this sequence go? We know there are infinitely many natural numbers, so this will never end. So it's a non-terminating. Okay, also, since I'm writing every time a different natural number than any of from previous, then every time I'm writing more digits, they are all different from this previous one. They will start repeating only when I start repeating the same number again and again. Like say after 15, I start writing 15, 15, 15 and all that. But I'm not doing that. So every next number is different, however big it is. So that also becomes non-recurring. So there is example, okay, of a decimal value, which is non-terminating as well as non-recurring. They don't end and they don't repeat. So such questions or such numbers, okay, cannot be classified in a set of rational numbers. Okay, so this set is what we classify as rationals. So there's a set of integers, okay, which are all negatives, zeros, and positives. And then there's a set of rationals. Okay, when you say integers, negative and positive, it means only the complete part, right? You can write them out in the discrete form, but for a rational number, you say P by Q, where P and Q are both integers, okay, and Q is not equal to 0. Your denominator cannot be 0, because if your denominator is 0, then we have a problem with that. We're going to see that later. So this is what is a classification of all the rational numbers. Okay, they are either expressed in a fractional form or in a decimal form. They are either terminating or recurring. Okay, then we define a set of all non-terminating and non-recurring values, rational numbers. right? Which is nothing but just the complement of rationals. So you can say any number which is not a rational is actually an irrational. So any number which cannot be expressed as a fraction will by default would be taken as an irrational number. Okay, so the whole theory of irrational is quite interesting, and in fact, the whole way, the idea of irrational numbers, the discovery of them again is pretty much marked in the history, because the person who first thought of an irrational number, Hippasus, he was a student of Pythagoras. Okay, he was actually killed by his fellow men. Okay, they were crossing the river, and one day when he ended up actually discussing the idea of it, and he actually threw him down in the river to drown. That's what the theory, the history says, because they never wanted, the concept of irrational numbers to come out, because that would actually throw the whole teaching of Pythagorean. It was totally challenging out in a different way. It was totally contradicting the whole thing of it. Because in the earlier days, during that period, church was a very strong authority. So everything that has to happen has to be in accordance to the church. You would have read that, even Galileo and all other, so many of these scientists has to face so much persecution from the church that were coming out with these laws that were totally in contradiction to the Bible and so on. So that was the Keynesian concept. So the problem was that, everything was that Pythagorean system deals with is related to integers and to a certain extent rational numbers also, because you can construct them by straight ruler and compass. So the basic rule for the Pythagorean system was that everything could be measured with just a ruler and a compass. You can measure those, distances, values and all that. So even fractional values can be measured through that. And it's a very interesting thing if you would go and read through that. And then there was a problem that somebody, and there was this one mathematician, okay, who came up with that, just to please the church. They said God created integers and the rest is a work of men, right? So church was okay with that case because there was God in the picture. Wherever there is God, he said, okay, fine, go do whatever they want. I will not trouble you. And hence the Pythagorean was given the liberty of teaching, and then they were doing that. But then this was something totally which was, not at all related. So this, and you can say that irrational set is just like a world in itself, right? They don't come anything from the previous. Just like natural numbers, whole numbers are set of integers. Integer is a subset of rational numbers, but you don't see somehow rational getting related to irrational, and that was a problem there because that was totally challenging out all the teachings, and that's the problem. So if you look at these numbers, you never know their actual values. Like you will always know the value, even if it is recurring, for any fraction. You can always link that out. You can represent them on the number line. But that was not true for irrational numbers because they are neither terminating nor recurring. So in reality, you can never know what is the value of an irrational number. You can just only approximate them, right? So the most celebrated irrational number is pi, and then there is a, which we use in a lot of scientific calculations, and then all the roots, root 2, root 3. Okay, 4 would simplify to 2, so therefore cube root of 4 and all that. So any nth root which is not further solvable would be an irrational value. And there are many other combinations like that. So pi is there and all that. In fact, and the recent way, to what I read last, pi had been found till I think 4 trillion decimal places, and still, there is no end to it. So there's this competition, in the US for $1 million who would break the previous record and add more digits to pi. Of course, they're all done by supercomputers and all that. Earlier, people would do that mechanically. They would sit and calculate 100, 200, 500, 1,000 decimal values of pi. But now it's all done by the supercomputers. In fact, it's one of the best stress tests that is done. If you know the first 1 million values of pi, you can run and actually check, how much accurate the calculations are and how fast it does. Okay, and even in our during some of the events in IIT, yes, and during the student days, we used to have this competition who remembered the maximum digits of pi. So if you go and see some of the websites, they have actually their poems where each word, it denotes the number of digits is equal to the the digits of a pi. So 3.1415, like that, right? So you have the words and the whole poem written in terms of that. So you remember 100,000, that one. There is this competition again for that. So the winner is some Japanese guy. I don't remember his name. He remembered pi till 40,000 decimal places, what from left to right and right to left and all that. It's all crazy things. So these are called as quacks. So if you go and read about them, so you will find a lot of stuff on Google and all that. Okay, but that's how the whole idea of the irrational ones. And then mathematicians said that instead, on working out this, why don't we combine the two? Okay, so they just combined both rationals and irrationals, and they called as a set of real numbers. Okay, so real numbers would comprise of everything which are terminating, non-terminating, and recurring, but also non-terminating and non-recurring. Positive, negative, zeros, fractions, square roots, cube roots, for only positive numbers. The word real number was given because you can always relate it to something in the real world. You can see them practically. And hence the concept of real line that was introduced, because you can actually plot them and see. So all these integers, comes with the gaps, that were discrete numbers. And then there are these fractions that you can also see in there, right? These fractions runs in there. So like if I have to represent a number like, 7/3, how would I do that on a number line? So we break it out. This is an improper fraction. We try to break it as a mixed fraction, which should be 6/3, that is 2 plus 1/3. So I would go on up to 2, and then I have 1/3 more. So I'll divide this into 3 parts, 1/3, 2/3. I need 1/3 more, right? So this is where you're gonna see your 7/3. As you remember in the school days, we used to do this bisection thing through, compass and ruler. That's what the basic Greek geometry is. The whole science that we study is basically based on the Greek understanding of that one. But if you look at that, Greek people, they all went actually to the Persia, and they borrowed a lot of their learning from Persians. So Greek happened to borrow from Persians, and if you see, these Persians had come down to India and have read and copied a lot of our scriptures and texts, and then taken there and then published that one. So, Persians copied from Indians, Greek copied from Persians, but now they are all being publicized as is a Greek philosophy, the Greek science. But if you see, a lot of things are actually linked to the Indian origin. In fact, the whole, the idea of trigonometry was actually first studied by Indian. So the word sine, okay, had this origin coming from the Indian language of the Indian relation there, because that means the word sine, actually sine cost, and the sine comes from the sinus, the Greek, which means a cavity, as we have that cavity on the nose, which is actually called as a jiva in a Sanskrit, and that is what you use to denote for an angle. So because basically it is about the relationship of angles with respect to the sides. So the angles were denoted in Sanskrit by jiva, which the Greeks, copied and replaced with sinus, and hence the sine, cos, tan came in. Okay, so it's very much given on the, on the net that the credit goes to the Indians and all that, but we never, had that much of it. Credit given in the real way. Now that was fine with all the fractions here, but if you look at how do you plot an irrational number? Okay, I'm just doing a little more discussion on this one because it's just a very interesting thing. Okay, and unfortunately, it is not being taught that much in that much in depth with this thing in the school level. So just a small time I'm spending in here. Once this, we just quickly run through the other parts and make it more relevant to the GRE thing. Okay, so This is very interesting. How would you plot irrational number on it? So it was a problem that was left unsolved by a lot of people for a long time. Okay, actually, it again got solved by using the the basic Pythagorean rule itself that what they worked out. So what they did that, let's say, how do I plot a root 2? Because the first irrational number that would concede was a root 2. So how do we plot a root 2 on the number line? So the construction or representation is very simple because I don't know the exact value of it. See, I can still know 2.333. I can represent that as a fraction. I can cut that part and go after representing, even if this is a recurring decimal, because every recurring decimal will have a corresponding fraction to it. And you can plot, plot a fraction easily by cutting it into these many parts and all that. But what about this? There is no fractional part of it. So I don't know how much fine I need to go about that. So I can say an approximately here, but then again, that is not the exact location, which defeats the whole purpose of defining them, although how much abstract it would be. So how do I find the exact location of a root 2? Okay, so for that, what we did is construct, a perpendicular of side 1. Okay, I'm so sorry. And another one taken a length of 1. Okay, let me just take a smaller version of it because otherwise this will not look like, an isosceles right triangle, because this is actually a right isosceles triangle. Okay, so constructing again a side of 1. So you have 1, 1, and then if I join this part, this axis. So what you see that this is 1 and this is 1. This one by Pythagoras theorem would measure root 2. Okay, so this one has a length of root 2. So I don't know how much it is, but this is what the length of root 2 would mean. So now I'm trying to construct, an arc of this much radius. So keeping, this thing at 0 and taking this measurement. So actually, I need to have an perpendicular drawn on this side so that I can draw an arc properly. So it would just be here, so that I can take the radius at the center O and work out. It would give me on the other side a minus root 2, that part. So this length is root 2. So I would take a compass, take it this much length, radius, and define an arc here so that it is actually a circle of the radius root 2. So even this length is equal to the radius, and hence this should also be equal to root 2. So this is the position of your root 2. Right. So now I can actually figure out where the root 2 is on the number line. Right. So that's how you can plot the irrational values on the R1. And then you can just, continue with this process. Okay. So you can keep on drawing these right angle triangles and then keep working on doing that. Okay. So let's say we started with a, simplest triangle. In fact, there was one of the question in one of the entrance that I've seen. There was 1, 1, this gave a root 2. Now construct another right angle triangle with side 1, join this. What would be this length? This is going to be root 3. Again, right angle triangle. So which is root 2 square 2 plus 1 square 1 would add up to 3 and root of that. So another right angle triangle with 1, join this. This is root 4, which actually would be 2. Another right angle with 1. This is going to give you a root 5. Okay, this one here, joined it here, 1, that will give you root 6 and so on and so forth. So you can literally construct the length of all the irrational numbers and keep on getting them plotted. So the question actually was, if you consider like that, what is the hypotenuse of the 35th triangle? Okay, so the question was, what is the hypotenuse of the 35th triangle? So when you see, in the count, the first one has root 2, the second one has root 3, the third one has root 4, the fourth one has root 5, like that. So the 35th triangle will have the measurement of root of 36, which is 6. Okay, so therefore it would measure as 6. Okay, so that's how you can continue with that one. Okay, so that was the whole origin and the idea of that. Okay, a good, interesting read. So, in fact, if you there is this History of Numbers, a book which has got 3 volumes, which is all talked about this one. A very, very interesting read that you can always look at. Now, coming back and see how this maths would become more relevant now to the GRE and all that. Okay, now again, some things that you need to be careful that where a lot of students make this silly mistake. So when you're finding the root, this is like say root 4. Now the value of root 4 is not plus minus 2, but it's only plus 2. Right. So when you say that x equals to root 4, okay, you won't say x is plus minus 2. The answer would be only plus 2. Because root 4 is a number, just like root 2, and it has to has a unique representation. So you cannot say that root 4 is plus minus 2 because that will contradict the basic fact that, it's not unique. The numbers are not uniquely defined. The whole again idea originated from the Greeks that when you're finding an x square, basically what is it? What is the meaning of an square of a number? So it denotes the area of actually a square of the side x. So if you have a square of side x constructed, each of this is x. So what is going to be the area of that? It is an x square. That's why it's called as the squares, which corresponds to the area of it. Now, the question is, if I know the area, can I go back and find the side of that? So I know if x squared is 16, then what will be the side of the square? That would be, do the, the reverse, the function on that one. So if we have first square out, we do the, the inverse of that, which is square root and 16 here, sorry, and that would give you 4. Since this denotes the side of a square, that's why square root values cannot take negative values because distances or length cannot be expressed as negative, right? So you have a square, x square call it, which denotes the total size of the square of it, x cube, basically, in that way seen as the total volume of a cube which has got length x. So x square corresponds to the area, x cube corresponds to the volume. Okay, but then later on, as you know, these are all called as fourth, fifth, sixth powers and all that. Because now you cannot see them, in the real world. You can only go up to either an area or a volume, right? So that's why you don't call them as x raised to 2 or x raised to 3. We use that a square or a cube term because you can relate to them practically. Okay, in fact, now since you would have seen an Avengers, we know about x raised to 4. This should be a tesseract. A tesseract is nothing but again a 4D analogy of a cube. Just like a cube is a 3D analogy of a square, a tesseract is a 4D analogy of a cube. So we'll say x square, x cube, x tesseract, and then so on and so forth. All right, so that's the reason. But here again, the difference when you say x square equals to 16. Okay, and the meaning of x equals to root of 16. There is a difference. Okay, now here x takes the value which is root 16, so x would be only 4. You would have only one value here. But when you say x square equals to 16, then I'm looking for all the values or all the integer values of x or the real values of x whose square gives me a 16. So we know that it comes from the 4, also from the minus 4. So that's why you have plus minus. Because I know only x square is 16. Now, from which number it came from? Is it came from the positive side or the negative side? We don't know. So that's why when you reduce a square to a, to an x, you put a plus minus because you don't know from which of the two sides it's coming. The value is root 16. So that plus minus comes from this purpose of reducing a square to a linear thing. Okay, and that's not always there. So if you see here, actually the sign is plus, not a minus one. So if the question it is given is x raised to minus of root 16, then I'll say yes, x equals to minus 4. But by default, it's not a plus minus. This is only when you're reducing a square to a linear function. And hence you can say that x in this case is plus minus 4, right? So when you reduce from a square to a linear, then you put plus minus. But if it is already a linear thing given, then you take only the positive values of it. Okay, this is again a very common mistake that I see, a lot of students making it. Now, moving in to another definitions, how these numbers are basically classified, the even, odds, multifactors, multiples. We all know about the even and odd, something which is divisible by 2. Odds would be things which are one more or one less divisible by 2. So even values, okay, when you would write, okay, going before that. So even numbers are the ones, which can be generally expressed as 2n, whereas odd are the one which are either 2n minus 1 or 2n plus 1. Okay, now if you look at the multiplication part, it's pretty sorted. Even into anything will always be an even value. So out of 100 numbers, if one is even, rest all are odd, it would just make the whole product even. Okay, one single even will convert everything to even. If the product has to be odd, then every single value has to be odd. Okay, you cannot have an even in the product, otherwise everything becomes even. All right. So if you look at the factorization of an odd number, then you can have only odd factors to it. You can never have 2 as a factor of any odd number. So 2 will never divide any odd number, as we know. So in multiplication, it is very clear. But when it comes to addition, you see, even added any number of times would always give you an even number, because you can always take a 2 common from everyone and then write the whole sum as a multiple of 2. But when you're adding an odd, then the answer varies. So add 2 odds, it's even, but add 3 odds, it's odd. 1 plus 1 is 2, but 1 plus 1 plus 1, you've taken 3 times is 3. So 1 added 15 times would give you 15, but 1 added 22 times would give you a 22. So when you are dealing with the sum of odds, you need to be concerned about how many odd numbers are there. Okay, the count will tell you whether the sum is odd or even. Okay, this actually can reduce a lot of time of your calculations. Instead of using numbers and substituting, you can just simply focus on the total count of odd in any addition based question where we are looking at finding the sum as being even or an odd. Okay, because evens are always evens. You just focus only on the odd numbers. So if the question is like, say, if I add all the natural numbers, starting from this up to 115, what will this sum be? An even or an odd? Okay. Now in this case, I would not bother about the even. I would see how many odd numbers are there. Okay. So all the evens taken together would get added up to an even number. Now, how many odd numbers are there? So if you see, it starts from an odd and ends with an odd. So you're going to have one extra odd than the even ones. So 114, would have 57. Yes. On GRE, 0 will be taken as an even number here. Yeah, I'll come to that. So 0 is an even number on GRE. In fact, all the negative numbers are also classified as even or odd. So when you see, as their base set that they have defined instead of natural is integers, so they have classified even or odds on the basis of integers only. So -2, -4, -6, -8, they are all even numbers. 0 is even. And now you see, if you compare this with a question on cat, because see, we here refer as a base set as integers, and we do classification on the basis of integers. So sorry, on the natural numbers, my bad, for us. So we say the smallest even number is 2, smallest odd is 1, and we never go into the zeros and the negative one. So we never have a question like this on cat which says 0 is even or odd. So that thing never comes into the picture, right? But on GRE, it's been extended to integers. So the concept of only the concept of even and odd is also extended to the negatives ones. So 0, -2, -4, -6, they're all even numbers. 1, 3, 5, 7, -1, -3, -5, -7, they're all also odds. So when it comes to classification of even and odds, do not forget to even take negative numbers, because sometimes you might find a contradiction with the negative numbers as well. Okay, so that's a point here, right? So you see here that there are total of 57 evens, but 58 odds. right? So they're gonna, sorry, so they have how many odds? There are total of 58 odds, which is even. Now all these 57 evens will add to an even value, but these 58 odds would also add to an even, and hence the entire sum would become an even. Don't forget that out, right? So therefore the whole addition would be an even. So in this case, you just need to mark out the total numbers of odds. Whatever is that sum, the final sum would be just decided by that. Okay. And also, if it's starting with an odd and ending with an odd, it doesn't mean the sum would also be an odd. It's all means, because if you have taken odd number of numbers, then what number is in the middle? So you can also imagine it like 1, 2, 3, 4 and 5. Now I've paired 5 and 1, so if you add two odd numbers, it would give you an odd. So if starting for an odd and ending with an odd, which would be true for odd number of numbers, you can make the pairs as even. So ye even pair hai, ye bhi even pair hai. Ab beech wala jo number is centralmost, that is odd. So therefore all the sums would become even, only the middle one is odd, and hence the sum would be odd. But if I would have taken, let's say in this case, I would have taken a value 1 plus 2 plus 3 plus 4 and a 5 and a 6 and a 7. Okay. This would be an even. This will be an even. This will also be an even. And the middle one here is an even. And hence the whole sum would be an even. So what we're doing is just pairing it out and just marking everything even. You can simply say, okay, जो centermost value है वो क्या होगा? If that is even, the sum is even. If that is odd, the sum would be odd. Okay, so that you can do for all the equally spaced numbers, because that's where it would be worked out. So all, natural numbers, multiples, you can use the same logic. Okay, so that's about the even and the odd properties. Also, when you use it in the exponential part, even raised to any power. Don't forget about, don't bother about whether it's even raised to even or even raised to odd. Basically, n tells you how many times you have to multiply the even number. So which is always the same with itself, and hence this will always be an even. So power doesn't play a role. It's all about base. If the base is even, the answer is even. If the base is odd, the answer would be odd. Just look at the base. Okay, forget about the power, because the power is just the repetition. It's odd into odd into odd into odd 10 times, or even into even 5 times. You're only multiplying evens or odds. So answer has to be even or odd accordingly. Okay. Now, then after even and odds, we look at, the concept of factors and multiples. This comes basically from the definition of a division algorithm, where we have seen that, this part is the dividend, this is the divisor, this is the quotient, and this is a remainder. So a very standard form that I would use thereafter would be A divided by B will generate a quotient Q and leave a remainder R. So hence we can write it as dividend is divisor into quotient plus a remainder. So A equals to BQ plus R. Now in this case, always remember the quotient Q has to be an integer value. Okay, that's the reason why you leave some remainder, and the remainder although could be 0 but can never be greater than your divisor, because if it is greater than the divisor, then you can always divide it by 1 and increase the quotient by 1 and reduce it. So if I'm dividing a number by 13, okay, there are 13 possible remainders, but that will range from 0 to 12, not 1 to 13. Because if it is 13, basically, it's one more of a quotient, and hence it becomes 0 eventually. So these are the two criterias on quotient and the remainders that you have. Now specifically, on GRE again, they define positive, divisors, and there is also a concept of negative divisors. So if I'll say what are the divisors of 12, then we know, 1, 2, 3, 4, 6, and 12. They will all divide 12, but so would be -1, -2, -3, and all that. So accordingly, because when you divide 12 by -3, the quotient is -4, which is an integer. So mathematically, there's nothing wrong with that. Okay, and that is basically expected. But since we are dealing with questions which are more relevant to practical, real real life problems where we don't see the concept of negative quotients. So therefore you would always have questions which will deal with positive quotients, where the idea is more about distributing things. So if 17 chocolates, needs to be divided among 5 kids, each one will get 3 and I'll be left with 2, because I cannot divide the whole entire 17 in a groups of 5. Okay, so everyone is getting 3, 3, 3, and I'm left with 2. That's why we deal with only positive things. So hence, in the questions, you would see on GRE, as they have to be very precise, they will say find all the positive divisors. They use the word positive divisor. They just don't use it as a find all the factors or divisors. See, for us, it's natural numbers. That's our base set. So there's no problem with the negative numbers here. But with integers, they have to be more clear. So positive factors, positive divisors, which just mean the same thing. Okay. Now, when you look at the factors for a given number, the number of factors are always finite. Like for 12, we saw 1, 2, 3, 4, 6, and 12. The number of factors are finite. But when you look at the multiples are nothing but the same number when multiplied with some integers, also called as the integral multiples. What would be those values? So 12, 24, 36, 48, and so on and so forth. The tables that what you used to deal with. There is no end to it, so that's infinite. Right. So the rules are you always have finite number of factors but infinite number of multiples. The largest finite factor of a number is the number itself, and the smallest multiple of a number is the number itself. You cannot have any number, a factor which is greater than the number, and you cannot have any multiple which is smaller than the number. Okay. And 1 is a 1 and n. Every number is always divisible by 1 and itself. These two are also called as the trivial factors. Every number will have them, and you can have some more factors other than these. Numbers which have only these as their factors are termed as prime numbers. The only factors are 1 and n. Okay, if you have anything more than this, some other factors, so number of factors is exactly 2. If you have number of factors to be greater than 2, 3 or more, then you term them as composite numbers, right? But if you look at 1, 1 has got only one factor. So the number of factors for 1 is only 1. Now, it doesn't satisfy the criteria for a prime nor for the composites. So poor guy cannot be a member of a prime or a composite club. So this remains alone. So we have classified as primes, composites, and 1, which is neither prime nor composite. So just like we can say that even is a complement of odd, or odds are complement of even, I cannot say the complement of primes are composite. So the complement of a prime would be 1 or a composite number, or the complement of a composite would be 1 or a prime number. Okay, and if the condition says n is greater than 1 and n is a prime, then you can say the composite are composites, because I'm excluding 1 from the definition and work out. Okay, now you need to remember and work on the total number of primes for the first 100 numbers. Okay, so we can just quickly, remember them. So 2, 3, 5, 7. Okay, I'm writing in the groups of 10, then 11, 13, 17, 19. Just remember them: 23, 29, 31, 37, 41, 43, 49. These are the first 50. So if you count, that's 8, 10. There are 15 prime numbers in the first 50. So between 1 to 50. Okay, then the remaining ones, then it is 53 and 59, 61, 67, 71, 73, 79, 83, 89, and 97. Okay, then in the remaining ones, you have 2, 4, 7, and then 10 other. So from 1 to 100, you see there are a total of 25 prime numbers. So these are the first 25 prime numbers. Okay, worked out. And for finding out generally in, primes, in case of multiples, they are infinite. So we don't ever talk about the, how many of them, because they are infinite in numbers, but the number of factors are finite. So we would be interested in how many factors a number has. Okay, so the questions about prime factors and the number of factors. So prime factor means the numbers only which how many prime numbers would divide that. And when you say the number of factors, everything, primes as well as a combination of prime. So there's this basic fundamental principle which says that every composite number can be broken down, can be written as a product of finitely many primes. Now, it's not necessary that every prime is distinct. You can have some primes as repeated, but every composite can be broken down as a product of primes. Okay, so primes are the basic constituent, the building blocks of the entire number system. It's just like, how atoms and molecules are that builds different elements. It's the same thing with, the primes. So you combine them. So if you look at 12, if you have broken down, this is 4 into 3, which is a 2 squared into a 3. So in order to make a 12, I would need 2 of the 2s and 1 of the 3s. Okay, because this helps a lot in, conceptualizing about finding the divisors and, the factors, and whether the number would be exactly divisible by them or not, because you can see what are the prime factors in that ones, which one is the one which they lack, and hence whether it would be divisible or not. So you can say, okay, what are the numbers or which are the primes that will make the part of it? Like here, you need, two of the 2s and 1 of the 3s. Okay, this is, if you look at it, it's very interestingly the same as we look at that one. So compare it with something like, say, H2O. In order to form a water molecule, you would need 2 of the hydrogens and 1 of the oxygens, right? So similarly, if you want to make a 12, you would need 2 of the 2 primes, and 1 of the 3. That works out. So there's also, something very parallel to that. Now, for the smaller numbers, it is fine, but how do you work for the bigger number? So let's say if I has a number 720, okay. Now, how do we find the factors and the multiples of them? So we're going to see that out, okay. Like, how do you work with these ones? So let's run through some questions in here and then, work it out on these parts. So the basic definitions, as we have seen. Okay, so talking of factors and multiples, it's just like two sides of the same coin. So in any perfect division, if you're dividing, so now A by B giving a quotient, right? If you have to name the numerator, you say numerator is a multiple of the denominator. So A is a multiple of B. And if I have to call B, we say B is a factor of A, right? So that's how you can classify it. So you see this, there's the same definition that works. Now, what are the factors of 15? What are the multiples of 10? We have seen factors of 15 would be only 3 and 5. And the total number of the prime factors would be 3 and 5. And the total number of factors are 1, 3, 5, and 15. Multiples of 10s are infinite, 10, 20, 30, and all that. Okay. Is 0 odd or even? Yes, 0 is even, but 0 is neither positive nor negative. Okay. 0 over divided by any other number is always 0, but no, 0 divides no number. So because if I have division by 0, it is basically not defined. Okay, now there could be a very simple, in fact, a logic to it. Okay, why? When you say anything by 0 is not defined, say it's 0 by 5. I don't know what the answer is. Let's say it is some integer k. So that means I should be able to find an integer which when multiplied by 5 should give you a 0. So does such a integer value exist, which when you multiply by 5 would give you a product as 0? Okay, because we are trying to find solutions in integers, but you've seen that this is an integer one, right? So we see there is an integer 0, which when multiplied with 0 would give you a 0. So anything about, 0 divided by any other number will always be 0. Okay, now if you use the same logic, in here to define 5 over 0, does 0 divides 5? Is 0 a factor or divisor of 5? If I don't know, let's say if it does, then I should get an integer k, because that's the quotient, which means if you cross multiply, I should get 5 equals to k into 0. Okay. Now, in order for this equation to be balanced, I need to have a solution An integral solution or an integer value of k, which when substituted here, should make the left side equal to the right side. So let's find an integer, which when multiplied with 0, would give you product as 5. I mean, what we see here that there is no such value of k. I cannot find. So therefore, there is no solution to it. And hence, we say it's not defined. You don't have an answer to that. And hence, division by 0 is not defined. Okay, this is a simple mathematical reason of why division by 0 is not possible. Okay, now we look at the basic concept of HCF and LCM. Yeah, for 2 or more numbers, HCF is the largest number that will divide, all of them at the same time, whereas LCM, is the least number which is multiple of all of them. So like in the first case, if you have to find the LCM of 8, 27, and 36, can you tell me what would be that answer? Okay, doing this basic stuff again. And if you look at the HCF of 48, 72, and 84, then what is the largest number that will divide all three of them? Okay, now you see that at least, 12 fours are 48, 72, 84, they're all the multiples of 12. So one thing which I'll try to do is quickly divide by 12 and see what are the results. So when you divide this by 12, each of them, okay, instead of going prime factorization, 12 4 times, 12, 8s are 72. No, 12, sorry, my bad. Okay. Uh, so will 72 goes on 12? 6 times 84, how many times? 7 times, right? So after I've divided this by 12, we see 12 fours are 48, 12 fives are 60, 6 are 72, 7 are 84. There is no common factor between these three numbers, 4, 6, and 7. If I would have had this as 8 or a 10, then I would have taken 2 more, and hence the new HCF would have been 12 into 2, which is 24. But here 4, 6, 7 doesn't have any common factor between all three of them, so hence we say the HCF would be 12. Okay. Likewise, if you would see here for the LCM, 8 basically is 2 into 2 into 2. 27, as we have seen, is 3 into 3 into 3. And 36 would be, it's 6 squared. So 2 into 2 into 3 into 3. So in order to find, we take as many commons that you can have and then multiply by the remaining factors. So you keep on dividing by them. So if you remember, we have done this, the prime factorization method, 8, 27, 36. So you can directly divide it by, 4. You can say 4 2s are 27 remain as it is, 4 9s are. And then you can actually divide by 9, which will not divide 2. 9 3s are 27 and 1. Then you can divide by 2 and by 3. So hence we'd see the LCM in this case would be, would be simply 4 into 9 into 6, right? So that would be the LCM of it. Okay, although, you have the questions which will not directly give you to find the LCM, they would be more about the word problems. So, when the things have to repeat at an equal interval, then it would be an application of your LCM. So when I say find a number which when divided by the, which would be the least number that will divide all the given numbers, or, a number which is divisible by all the numbers, that would be the LCM. And a largest number that will divide all the given numbers, means it has to be a factor, that would be the LCF. So the key is to see that, if a number has to be divisible by the given numbers, then it's the LCM. And if a number has to divide all the given numbers, then it has to be the HCF. Okay. Now, moving on to this part, which we have seen in the division algorithm, the same thing that we have only discovered. Now, let's move on to the questions directly. Yeah, 216 is the answer for that one. So remainder when a positive integer n is divided by 5 is 3. What is the remainder when 2n is divided by 5? Okay. Now what would be the easiest way to work on this? Just take a value of n. Okay, so what you see that here n, you can write it as when it's a when you divide by 5, that means it's a multiple of 5. It's 3 more than that. Okay, so n is of the type 5 cube plus 3. Okay, instead of taking just one number and then, finding out the answer and writing out, you at least repeat for a couple of values and see if you get the same answer, just to be, double sure that the answer will not change or give me a different value. So a remainder when, positive integer n is divided by 5 is 3. So that means 5 is the, the divisor, q quotient, and the remainder 3. We can write that n here. Now, what could be the different possible values of n that we can choose here? So the smallest quotient value that you can take, because we're dealing with only positive things, could be 0. Quotient is an integer. Once you go for the negative, you get n negative values. We're dealing with only positive integers. So the smallest q value that you can take is 0. So 0 plus 3, which will be 3. And then it will be 5 plus 3, 8, 10 plus 3, 13, 15 plus 3, 18, and so on and so forth. Right, so these would be the different values of it. So whenever you deal with the multiples of 5 and some remainders, you see there would be the same cyclic pattern that you get. Just like you have first 3 and 8, then it's going to be 13, 18, 23, 28, 33, 38, and so on. So you see that these ones which generate the remainder of 3 are also equally spaced with the gaps of 5. So just like all the multiples of 5 are equally spaced, so would also be the numbers which generate the same remainders. So if I'm saying which are all the, or how many such multiples are there, okay, of 17, that would, give me a remainder of 7. So I'll say the first number, which will give you a remainder of 7 when divided by 17 would be a 7. And the next number thereafter would be just 17, and that's 7 plus 17. Because all the numbers which will generate a remainder of 7 when divided by 17 will also be equally spaced with a gap of 17. So then it's going to be just 7 and 17, which is 24, and hence with the gaps of 17 each. So you can just use the same factor, the same logic to generate all such numbers. So n is this, we can quickly see 2n would be double. So what is the remainder when 2n is divided by 5? So this is 6, oh no, this is 16. This is going to be 26, 18 double, which would be, 36. So what we see that everything is just ending up with 6. 3 double is 6, 8 is 16, 13 is 26, 18 is 36. The same pattern would repeat. And when you divide this by 5, we see the remainder in every case is 1. So hence, we can say that the remainder would be always 1 in this case. Okay, instead of just taking one number, which would anyway give you a 1, in some cases, it happens that it follows a different cyclic pattern. You may not get the same remainders, but different. Okay, like in a GRE, we have, MCQs where you can have multiple correct entries. So there you can have more than one possible remainder, and then it becomes important to see for larger values that which are the different remainder sets that will be generated. And I have to mark all of them there. So for the box one, you'll always have a unique answer. So shouldn't have bothered much. One would be sufficient enough, but for others, you need to work. Okay, so that's one. Now, these are the comparison questions where, I need to mark which of the two quantities is greater. If A is bigger, in a numerical value, they'll always result in some numerical value. So if A is bigger, we mark A. If B is greater, you mark B. If they both are equal, you mark C. And if there is more than one possible relation, means they could be greater than or equal to, or less than or equal to, then in that case, you mark D, because I don't get a definite answer from that. Okay, so we see, which one would be true. So M is PQ, such that P and Q are different positive integers. Okay, Q is when an integer when divided by a remainder when n is divided by M. B is a remainder when n is divided by p. Okay, I give you a minute, try out and tell me the answers. So for every question, okay, I give you a time, okay, not more than 1 minute. In some case, it won't even take a minute. It could be less than that. You just have to quickly work out the problem, type your answers here, okay, on the chat box, and then we go to the discussion. Okay, so now just work out quickly and tell me what would be the answers. Ayushi, you think it's A? Are you always going to get A? Will A would always be bigger than B? Okay. Okay, so there's a D, there's an A, there's a C. Guys, I would request if you can post the questions on the chat box. I have, set of questions in here because then I'll have to refer to two different sets at the same time. So if you can also post it on the chat box, becomes easy. So some of the questions here will be solving questions. Yeah. We will do that. There was just a little extra discussion here that I did. Otherwise, we'll spend most of the time on the questions, which is the smallest even number. There is no answer to it because it can go to minus infinity, minus 2. Oh, sorry. Did I write prior 49? My bad. My bad. It's 47, not 49. I might have just mistaken there. I didn't realize that. So 41, 43, and 47, not 49. Okay. Thanks for correcting, Abhishek. It's just a simple, typo mistake. So 41, 43, and 47. These are the primes. 49 is not a prime. It's a 7 square, in fact. Okay. Okay. D, C, B, D is in that one. No, see, in such questions, the the best way to work is to find out a contradiction. Can I change my answer? So you first take an example and see which options you get. It's A, B, or anything. And then you see, can you take an example which will just try to contradict it? Because it's very easy to find a contradiction. So here it says M is equal to P into Q and R. So I can say, let assign some values to it. So M equals to P into Q. So let's Q here. So let's say P is 2, Q is 3, M is 6. So P2, Q3, M6 for some set of values. Okay, for different positive integers, we have taken different sets. Okay, now N is some number. So let's say N is 10. This A in this case is a remainder when positive integer N is divided by M. So 10 is divided by 6. That's 4. In this case, a remainder when N is divided by P. So here 10 is divided by 2. Okay, it's a remainder. So therefore 0. So you see that this gets 4, this gets 0. So A is bigger. Right, so I can get an answer in which quantity A is bigger than B. Now try to take different numbers. So let's say what if n was 12? Then here I'll divide 12 by 6. That will give me a 0. We are looking at remainder, not the quotient. And again 12 by 2, which will again give you a remainder of 0. So you can also get a 0 and a 0 for A and B, which can make it equal. So you can have a quotient, your remainder and quantity A greater than B. You can also have a quantity A equal to B. So both the cases are possible, and that's why we mark option D. Okay. So understand, what is an approach that I need to take for this one. Take first one set of numbers, see what you get, and then try to take another set where you try to find a contradiction. If you can get a contradiction, then it's easy. If you cannot get a contradiction, then it would be a problem. Then, I mean, you need to continue. You're going to get the same consistent answer, right? And hence the answer should be either always A or always B. That becomes more evident as you look at it. So just always trying to contradict and cancel it out, right? So which you see option D. Answer D is the answer. Okay, yeah. Prime numbers as we have seen. Okay, my bad for that correction, please. Okay. 49, as I don't mistakenly, is not a prime. It's a perfect square. It's a 47. So the three primes there would be 41, 43, and a 47. That one. So we just did that earlier. Okay, although it was supposed to be just a homework thing, but doesn't matter. Number of factors. Okay, now what is the number of positive factors of 200? Like working out quickly and finding out how many factors you would have. Okay, would this be thing would have. So how do we quickly figure out the number of factors for this? Okay, in fact, it is interesting thing. We're already at 5:02 because I have another session which is lined up. Okay, so what I'll do is, in fact, we have the second session on Monday, which will be the continuation of this one. So number system, generally, as I enjoy, talking about the whole evolution of numbers, it's just one of my favorite areas. I've done my research in, number theory. It's what I was researching actually. So it is one of a very, favorite area of mine. So that's why, I ended up talking a lot about the whole evolution and all of it. Okay, just for that. But now we're gonna go with the flow. So we're just gonna work normally with the things that are relevant to GRE and all that. So what I'm saying is, although there is a lot of variations with the number of factors, how you calculate the number of factors, what is the logic behind that, and a very efficient method that we can work out, and how you can also raise the level of difficulties. Means you can have a very direct questions like this, finding the number of positive factors of 200. But then if you have to keep stepping up the level of difficulty, how the questions would transform, what conditions would change, and how do we change our method in order to find that one. So that would take some time, I would say another 15 minutes of solid discussion only on the factors and working out, and that might just delay me for the next class. So what I'm going to do is, okay, I'm going to continue, let's say pick up from here and actually start on the next session and go through all the parts, the left part of the number system. Okay, so we're gonna continue with this one in the next session. I think the next session of the quants is scheduled on Monday, right? We'll meet again. The time would be confirmed to you. We'll just, let you know in that case. Guys, is there any group that all of you are part of? Any WhatsApp group or anything that has been made specifically for you? You're all there, right? And oh, that's great. And who's coordinating that? Is there any admin or someone? Is one of you an admin from there? Because if you guys are, then maybe some Samyuk, right? Okay, Samyuk. So can you also add me to that? So because in case if I need to, send any updates. Acha, okay. So I understood that. Sure. Okay. So okay, take it, fine. So I think Prem sir is the one who's from our side. Okay, so I'll share my number. So maybe if you want, you can please add me to that one. So if there's any communication, about the classes part and all that, and something that I would also like to share additionally, some practice sheets and all that, I can post on there, right? So I'll just write down my number here. Okay, so you can get me added to that one. Okay. All right. So from the next session, we will just quickly run through the theory part on the factors, and then we go after solving the questions. And see, when we are doing the questions, it's just more of a fast solving part, because see, when you are taking the real test, the only thing that you need to work is on your timings, because if there are one or two odd questions which ends up a little time consuming, something like say a DS set, sometimes you have some big DS sets which takes time. So GRE is a speed based test, so all you need to do is questions which are quick, should be done quickly. Okay, so that in case you have some lengthier questions, you have enough time to work on that. And since you ensure that you don't make mistakes, because the accuracy needs to be very high, you should have time enough to go back and again cross check on your calculation, so that you can find out if there is any silly mistakes that you have done. So what we'll try to do is just work with one limit time, 1 minute time thing. So try to work out every question in less than a minute, so that you know we get used to that timing. Well, I think that's usually how I solve. If you guys are okay with that, you can let me know, or maybe we can just go question by question that discussion instead of that one. So I'm totally open to that. You can just let me know, and it will be more of the problem solving, okay, than this one, than the theory part, because theory usually would not take more than 15-20 minutes to recap, okay, and then it's majorly about solving the problems. So that is what we would be focusing on. Okay, it was just the intro part, so the first half has just been gone into that part, right? Okay, so I'll post that on the group, and we'll connect back on Monday where we pick up from here, right? Okay, guys, it was definitely fun interacting with you, although uh, it's not as live and interesting as it would have happened in a classroom environment, but still, it's fun to have a class of nearly around 60 people, and I'm really looking forward that we can have a lot of interaction, a lot of discussion, okay, on every session thereafter. Okay, so I'll sign off for now, guys. Take care. Goodbye, guys. Stay safe, and we're gonna resume with this part of number systems in the next class. Okay, thank you so much. Take care and goodbye. Thank you, everyone.